Everybody getting that? So I'm going to go 10 over 1.2. You can just put cubic centimeter over grams equals, and the 44 is cubic centimeters, so it's going to have to go on the top and the x on the bottom. Does that make sense how I decided that? I just followed the trail of the units. Units saved me in physics. I didn't really like units before physics. I took physics and units were helpful to me. So you just follow the units, you can tell which goes where, right? Cubic centimeters on the top, so 44 goes on the top. All right, and then just diagonal. 10x is 1.2 times 44. 10x is, what's that number? 52.8, thank you. And the last step is divide by 10. X is 5.28. Did y'all get that? That good? Are we okay there? So they give you three numbers. The fourth one's x. Cross multiply, solve for x. No questions? It's easy. Can I flash off of that? Okay, so this one. It is known that making, so 1 pound of honey is 20,000 trips by the bees. So how many pounds for 35,000 bee trips? I have a lot of peanut butter and honey sandwiches. I think I'm costing the bees a lot of work. 20,000 trips for a pound of honey. I probably eat a pound of honey every month, or maybe more. Okay, so set that up. It's just, there's three numbers. The fourth one's an x. Just make sure you don't get anything upside down. Use your calculator. These are a lot easier than the travel problems. Okay, so 1 pound of honey, 20,000 trips, x pounds of honey, 35,000 trips. Good? Right? Just two equal fractions. Diagonal. 1 times 35,000 is 20,000x. That means, and bring it up here, that means 35,000 is 20,000x. How do you solve for x? Divide by 20,000. Boom, x is, what is that? Now, to reduce that fraction, 35,000 over 20,000, just first off cancel the zeros, right? It's 35 over 20, and then divide by 5. Top and bottom, was that 7/4? And they might want just a decimal. Isn't it 1.75? Maybe they just take a they probably just take a decimal. Yeah, probably won't. You just divide from the beginning and get 1.75. Whatever, decimal fraction, whatever. Is that good? We okay? So 35,000 trips would make 1.75 pounds of honey. I'll move on if you're okay. How do they count fish in the lake? Deer on the mountain? Rabbits in the field? How do biologists count critters? How do they do it? Anybody you ever thought about that before? You ever read Field and Stream magazine or some biology report and seen how they do this? They, think about it for a second. How would you count a fish in a lake? I mean, what are you going to do? Even with advanced technology, sonar, still, what are you going to, you go over and kind of those little blips are all moving around down there, trying to keep track of them all. That would not be a good plan. And not only that, how about if they wanted to know how many trout in the lake as opposed to how many bass, right? It's not going to be able to tell the difference on a blip. So how do they do it? Have you ever heard of catch, tag, and release? That's how they count critters. They catch them, tag them, release them, catch them again a week later after they've been mixed around or so, and take their proportions. They do fractions like we're doing right here. Let me give you a feel for that. What if, let's say we caught, suppose we catch, tag, you don't need to write this out. I'm just going to reason with you logically, then I'll give you the formula. So I don't want math to just be, step one, step two, here's the formula. Just think with me for a second. What if you catch, tag, and release, I don't know, 500 fish? What if you have a big net, you're the biologist, you go out in the lake, you just throw down a big net, you whop up 500 fish, and you tag them, and then you release them. Well, that's probably a lot, huh? Let's say you just do 100. Catch, tag, and release 100 fish, right? You let them go again. They're swimming around again. 1 week later, and the significance of the week later is just give them time to mix around again. Could be a weekend, whatever. Just give them a little time to mix around again for randomness. 1 week later, let's say you catch 50, and, well, let's say you catch 50, yeah, and 25 have tags from last week. Get the idea? A week later, they mix around, you catch 50, you look at them, you go, huh, half our fish have tags. 25 out of 50. Any ideas how many fish might be in that lake? Let's think about this. If I go out on the street and I randomly survey people and ask who they're going to vote for in the next governor election or whatever, they all, half of them tell me Joe Blow is going to be who they're going to vote for, then I would think that half the people maybe in the whole state are going to vote for Joe Blow, right? You use a sample to tell you something about the whole group, right? So if I grab 50 fish, a week later, I grab 50 fish and look them over, and 25 of them have tags, that's half of them, huh? So I'm thinking not only are half the fish in my little sample tagged fish, but probably, I just grabbed them at random, that's representative of the whole lake. Probably half of the whole lake is tagged fish, right? Does that make sense? If half of my little sample, that's what you do with polling for an election. Whatever you get in your little sample, you assume that's true for the whole thing. So if you have half your fish are tagged fish, had the tags from last week, or tagged fish, probably, in your sample, probably half the fish in the entire lake are tagged fish. Okay, so what? Well, you know how many fish have tags because you tagged them last week yourself. There's 100 fish in that lake that have tags, assuming none of them died during the week, right? There's 100 fish that have tags. And you're thinking, well, I just grabbed a sample, and my little sample, half were tagged fish. So probably that's representative of the whole lake. Probably representing the whole lake, that means half the fish in the whole lake have tags. I know there's 100 tagged fish, so how many fish in the lake? Probably about 200. Does that make sense? Does everybody see that? How that's a way of estimating the number of fish in the lake? Right? Right? Because my sample, half the fish have tags in my little sample. So probably half the entire lake. I just grabbed these guys at random. Half of them had tags, so probably half the whole lake has tags. I know there's 100 that have tags as I did it, so probably about 200 in the lake. Half. 100 is half of 200. So they would have an estimate, we think there's about 200 fish in the lake. So that would allow them to estimate. That's exactly what they do. With rabbits in the field, deer in the forest, fish in the lake. And that way they can do a particular kind of fish or a particular kind of rabbit. They can say, we just want the brown spotted rabbits. So they grab a bunch of rabbits. They tag only the brown spotted ones, let them go. A week later, grab a whole bunch of rabbits again, let all the ones without brown spots go. Look at the brown spotted ones and say, looks like, 30% of the brown spotted ones in our little sample have tags, so probably 30% of all the brown spotted ones are tagged. We know how many are tagged. They can estimate the number of brown spotted rabbits in the whole field. They can be specific that way. All right, so that's the theory. That's how it works. So it's an estimate from sampling. It's like you're asking the fish who they're going to vote for. You're asking them with a tag. All right, so here's the formula. For your first catch, it's tag over total equals, and your second catch, it's tag over total. So that's the formula. It's two equal fractions. That's why it's in this word problem section, because it's just two equal fractions. tag over total equals tag over total. First catch, second catch. Because the percentage of fish with tags in your little sample has got to equal the percentage of fish with tags in the whole lake, since you just grabbed it randomly. Okay. Let's do it. 608, here comes the first. Again, so same thing, they're going to be three numbers. 618 deer. What does he do with them? He tags them and lets them loose. So those are the 618 tagged deer in the first catch. Later, see the word later? That means here comes the second catch. Later, 426 deer caught, 213 are tagged. So 213 tagged over 426 tagged. See how they're giving me those numbers? So first catch, 618 tagged, caught, tagged, and released. Second catch later, 213 were tagged out of 426 that they caught later. X goes down here, right? Cross multiply. Same thing. 618 times 426 equals 213 times X. What's 618 times 426? Somebody have that in the calculator?
263,260.
260 or 16?
263,000.
Yeah.
260.
268?
Yeah.
Oh, okay. I could have done that in my head, but I hate to show off, so I just let you help me with the calculator. Thanks. We get to there, and then divide by that 213, right? To get X alone, 213. Let me see. Wait, I can do this one in my head. It's going to be 1236. I'm doing a trick. I can't really do that in my head. It's got to, see, this is half, you know, so it's going to be double. So, anyway. So, there it is, 1236. There's our answer. There's approximately 1236 fish in the lake. Is that good? Does that make sense? Questions on that? I can't read you guys to save my life. Just give me the straight look. Give me the no, a frown, or a yeah. Then I'll know whether to speed up or slow down. All right.